All right, welcome back today, guys. Today we're going to be doing lesson chapter 8.3.3. How can I compare them? We're going to be using something called a unit conversion. So read along with the introduction.
Have you ever heard someone use the expression, they are like apples and oranges? Usually the person talking means that the two things they are talking about are so different that they are hard to relate to each other. For example, it is very hard to decide whether or which is heavier, 1,000,000 feathers or 1,000 bricks. The information you have does not describe their weight, and the two kinds of objects are so different that trying to reason about which is heavier is very difficult. To compare two things, it is useful to find ways to relate them to each other. Often, quantities cannot be compared without doing some calculations or rewriting them in equivalent forms. As you work today, think about the quantities that you are comparing and what you need to do to be able to make a good comparison.
So question 106, our first core problem for the day. Rob and Marla are going for a run. They typically run an average of 5 miles in 1 hour, as represented in the diagram here at the right. Today, they plan to run for 40 minutes. So notice in this diagram, we are comparing miles and hours. They're both, this is distance and this is time. But the question is asking us about how far could they run in 40 minutes, which is still a unit of time. So we want to think about how we can compare distance and time, but our units are going to change. And we saw this in one of our problems from yesterday when we were comparing the number of bags we bagged of groceries and time. So 1 hour is equal to 60 minutes. So we can actually change this diagram or add on to this diagram showing that 5 miles is equal to 1 hour, which is also equal to 60 minutes. So you guys can see I went and read through this diagram here. You guys should now have it in your notes as well. And we're still comparing the measurement of distance 5 miles in 1 hour, but 1 hour is also equal to 60 minutes. So question A says estimate how far Rob and Marla run in 40 minutes. Remember that an estimate can be done with only simple mental calculations and does not need to be an exact answer. So we're not looking for an exact answer to this problem. So go ahead and take about a minute, go ahead and pause the video and see about how far do you think they're going to run in 40 minutes.
So we're estimating here. Estimate how far Rob and Marla run in 40 minutes. So we know that right now they run 5 miles in 60 minutes. So for estimating, we know that in half of that, so half of 60 minutes is 30 minutes. And half of 5 is 2.5.
Okay, so we know that 40 miles is a little bit bigger than 30, and so therefore we would. I'm sorry, this is minutes, not miles. In 30 minutes, we're going to go about 2.5 miles. So we're going to go a little bit more than 2.5 miles. So somewhere between 2.5 and 5 miles might be your estimate. Okay, that's one way to approach it. For me, if you guys think about it another way, I may have said, well, hey, that 5 miles. I can divide into 5, so I can think about this as 5 equal sections. In my head, I can do 60 divided by 5 is 12. So I know that this is about 12, 24, 36, 48, and 60 minutes. So each of those intervals would be 1 mile. So for me, I can say that 1, 2, I'm going to be somewhere between 3 and 4 miles. So that might be another estimate. So the important thing is, though, that we know that less than 60 minutes is going to give us less than 5 miles. And we should definitely be able to know that a halfway point, 2.5 miles is only 30 minutes, so it should be above that. So we can definitely narrow it down between 2.5 and 5 miles.
So moving on to question B. Marla said, I know that to find distance, I need to multiply rate times time. Multiplying 5 by 40 gives me the answer of 200 miles. Do you agree with how she organized the problem? If not, explain what you think she did wrong and what you think the actual distance should be. We are going ahead and give you a few minutes to complete this problem And we are not going to come back on and explain this because this question is actually going to be for a grade. So take your time, think about it, and give it your best shot.
So in class, you guys would see this as a stoplight problem. This would be more like a journal entry. So when we're grading your this as a question, it's gonna be a journal entry. Did you guys answer the question, or did you guys explain? So there's not necessarily a incorrect or correct answer. Did you guys explain? Did you guys agree? And if not, explain what you did wrong. All right. So moving on to question. Actually, I guess go ahead and pause the video. Take some time to fill out that journal. Again, no wrong answer as long as you guys have answered the prompt and explained why or why not. So question 107 says, we in GenFi, I'm not sure if that's the correct pronunciation, like to let their pet gerbils run on a small track. Wei thinks her gerbil can run faster than GenFi's gerbil, but GenFi disagrees. They decide to take some measurements and compare them. Wei's gerbil runs 2 yards in 20 seconds, and GenFi's gerbil runs 20 feet in 1 minute. With your team, we want to determine whose gerbil is the fastest. Use a diagram to justify your answer. Record your calculations carefully so that they are clear enough for someone else to understand. So Miss Lanza and I are going to take...
I call GenFi.
So that's I have Wei. And we're going to talk about whose gerbil is the fastest. And remember, you guys have to use a diagram to justify your answer. So go ahead and pause your video for a couple of minutes. Go ahead and create a diagram for Wei and one for GenFi. They do not need to look like ours. There's lots of different ways to draw and represent diagrams. The important thing is here is, can you guys justify whose gerbil is running the fastest based upon your diagram? So go ahead and pause the video. All right, so for Wei, I went ahead and started with the rate they gave us, 2 yards in 20 seconds. I took half of that to find my unit rate, so then 1 yard took him 10 seconds. So 3 yards would be 30 seconds and so forth. So I used a T-chart to go ahead and graph that to show how to compare the distance and time for my gerbil. What'd you do, Miss Lanzo?
GenFi. Well, he did 20 feet in 1 minute. So then that's my unit rate. So then I added, for 2 minutes he went 40 feet, and 3 minutes he went 60 feet. But guess what, Mr. Baldwin? I noticed that yours says yards in seconds and mine says feet in minutes.
Well, my gerbil is clearly faster because I have 2 yards in 20 seconds, and you have 20 feet in 1 minute.
No. Mine's fastest.
So we have a problem. We both did a table for our gerbil, and we both have correct tables for our gerbils. But what you guys are going to notice is that Wei is comparing yards and seconds, like Miss Lanza said, and GenFi is feet and minutes. So we have to think about how can we compare apples to apples and not apples to oranges like they said in the problem. So we want to think about, we have talked about the connection between seconds and minutes, and we know that there are 60 seconds in 1 minute, but we also know that there are 3 feet in 1 yard. So we can change one of our tables to relate so that they are the same thing, feet and minutes. And for each of us, it may be different. For me, I'm going to say that it's probably easier to change, what, minutes into seconds? Okay, so if we change minutes now into seconds, 1 minute would be how many seconds?
60.
2 minutes would be
120.
And 3 minutes would be 180. So we still have feet per seconds, okay? But I have yards per second. Okay. Well, we know that every yard is 3 feet. So if I make my yards now into feet, I know that 1 yard is how many feet?
3.
3 feet. So 2 yards must be 6 feet. 3 yards must be 9 feet. And 4 yards must be 12 feet. So now, for Wei, I can compare 6 feet in seconds and kind of ignore this column right here. So now I'm comparing feet and seconds. And for Miss Lanza, for Gen 5, we can compare feet and seconds as well. So now we're comparing the exact same numbers. So what's our next problem?
We don't have any seconds that match or any feet that match.
So what do we do?
I think either you should add on to your table or I should add on to mine.
Okay. I think it's usually, for me, it's usually easier to increase than decrease. So if I have 40 seconds and I add an additional 20 seconds, I'm now at 60 seconds, right?
And I have 60 seconds.
So here's 40 and here's 20. So I'm going to add the feet that my gerbil traveled. 12 and 6 would be 18.
Yes!
So that means my gerbil traveled 18 feet in 60 seconds.
And my gerbil traveled 20 feet in 60 seconds. Mine wins.
I think she cheated. All right, so mine traveled 18 feet in 60 seconds, and Gen 5 was 20 feet in 60 seconds. So in the same amount of time, my gerbil went 2 feet less, and Gen 5 went 2 feet further. So which one would win the race? Miss Lanza? All right, great job. If you guys didn't quite get as far on your own, take a minute, pause the video, review the video if you need to, and talk about how do your units relate to one another, and how can you guys convert from one unit into another. All right, so go ahead and pause the video. We'll be back with you guys in about a minute. All right, so we're going to go ahead and skip ahead a little bit to question 112. We're still going to use information about Gen 5 and Wade that we used earlier in today's lesson, so don't go ahead and get rid of that quite yet. It says, use your understanding of the relationship between distance, rate, and time to answer the following questions. Letter A, Gen 5 and Wade let their gerbils run for 90 seconds. How far does each gerbil run? And then B says, if Gen 5 and Wade let their gerbils run for 30 seconds, how far apart will they be and whose gerbil will be in the lead? So let's go ahead and do letter A first. How far would they be after 90 seconds? So if you look at the table, we went ahead and simplified our table from earlier. We know that after 60 seconds, Wade traveled 18 feet. So if I add an additional 30 seconds here to get to 90, so 60 plus 30 is 90. So I'm going to go ahead and add my feet. 18 plus 9 is 27 feet. So after 90 seconds, Wade would be 27 feet ahead.
So I know that my rule is you multiply it by 3. So in order to get back, you have to divide by 3. So 90 divided by 3 would get you 30.
So in 30 feet, it took you 90 seconds, and in 90 seconds, mine only went 27 feet. So that still corresponds to what we talked about earlier, that Gen 5 is traveling at a faster rate. Now, if you notice Gen 5, Miss Lanzo's, her rule was to either multiply or divide by 3, depending upon where you're going from feet to seconds or seconds to feet. So we're still going to use the same logic over here. So we have to find a number that you guys can either multiply or divide to go back and forth. So 6 times what number would give us 20, or 20 times what number will give us 6? So we know that 6 times 3 1/3 is going to give us 20. Okay? Or 20 divided by 3 1/3 is going to give us 6 feet. How do we get that? We take our two numbers. 20 divided by 6 is equal to 3 1/3. And now we look at it. Do I multiply 6 by 3 1/3, or do I multiply by 3 1/3 to get to 20? Okay, so that sets up our rule here. So we could have taken 27, followed our rule up here of multiplying by 3 1/3 to give us 90. So we took our distance, and we multiplied by our rate to give us our time. Or you could take your time and divide by your rate to give you the distance. So going back to letter B, if we let our gerbils run for 30 seconds, so Wei, my gerbil would be at 9 feet, and
I have to convert mine. So I'm going to take my 60 seconds and divide it by 2 to get 30, and take 20 divided by 2 and get 10 feet. So mine ran 10 feet in 30 seconds.
so mine would have gone 9 feet for every 30 seconds. And Miss Lanzo's Jinfei would have gone 10 feet in 30 seconds. So Jinfei still is ahead. So in 30 seconds, her gerbil went 1 foot farther. So how far apart will they be, and whose will be in the lead? We said that Jinfei will be ahead by, what's 10 minus 9? By 1 foot. Last question. If Jinfei and Wei race their gerbils across a room that is 12 feet long, by how much time will the faster gerbil win? So we already know that Jinfei is going to be our winner, but now we have now we're not going to compare time. We're going to compare the distance that they traveled. So luckily for me, in my table, I already have 12 feet right here, and I know that in 12 feet it's going to take 40 seconds for my gerbil. So Miss Lanzo, in yours, you also need to find in 12 feet how far that would go. So using your rule, you're going to multiply 12 by what number?
Well, I was thinking that I can take 60 to get to 12. And if I do 60 divided by 5, I get 12, right? So if I do 180 divided by 5, I should get 36.
So does that match your rule up here of multiplying your feet by 3? 12 times 3 is 36. Yeah, so there's lots of different ways to go ahead and find the answers to this. So we both found out that 12 feet, my gerbil would take 40 seconds, your gerbil would take 36 seconds. So the problem says, how many feet?
How much time will the faster gerbil win by? So if yours is 30 and mine's 36, 36 minus 30, I'm sorry, is that right? No, it's up here. I'm sorry, it's 40. Yours is 40 and mine is 36, and if you subtract those, they win by 4 seconds. I win by 4 seconds.
Okay. So in a race, we would go the same distance, but I would be 4 seconds slower, Miss Lanza would be 4 seconds quicker. All right, last question for today. Core problem 113. A professional speed walker who is training for the Olympics can walk 2 miles in 16 minutes. Calculate the following rates. Refer to your math notes box following this lesson if you need help with unit conversions. So in this problem, they are comparing two things. They are comparing 2 miles in 16 minutes. So right away, we know that's our ratio of what we're comparing. That if we were doing a table, that would be what we would have our T-chart set as 2 miles in 16 minutes. So so that's what I'm going to go ahead and do. So I'm going to go ahead and compare time and distance. Okay, what was that rate one more time, Miss Lanza?
The rate is 2 miles in 16 minutes.
So again, our time should be in the time column, and our miles should be in the distance column. So letter A says, what is the athlete's minutes per mile? Minutes per mile. So if we're trying to find out minutes per mile, okay, we already know that in 2 miles it takes 16 minutes, so in 1 mile it would take 8 minutes. Okay, if you didn't want to draw your table, and you know that you want minutes per mile, we can substitute those in with the rates they give us. They originally gave us 16 minutes, and that was for every 2 miles. So what is 16 divided by 2? 8. 8 minutes for every 1 mile. Same thing we found here in our chart. So two different ways to approach that type of problem. Letter B says, what is the athlete's miles per minute rate? So because we're now, earlier in letter A we did minutes per mile, now we're doing miles per minute. So now, miles per minute is what I'm comparing. So we plug in, instead of 16 minutes to 2 miles, we plug in 2 miles for every 16 minutes. So instead of up here we did 16 divided by 2, now it's 2 divided by 16. 2 divided by 16 is 1/8 of a mile for every 1 minute. So remember, ratios are just fractions, and fractions are just division problems. So for letter A, we were able to compare minutes to miles, and in letter B, we compared miles to minutes. In letter C, it says, what is the athlete's feet per minute rate? And D says, what is the athlete's feet per second rate? So go ahead and pause the video, take a few minutes, and try those two different ratios on your own. And we'll be back with you to review these in a few minutes. All right, so we're going to go ahead and use what we know from A and B to answer C and D. So in letter C, we are asking, how many feet can we go in 1 minute? All right. So using letter A over here, I know that in 8 minutes I can go 1 mile. So where it's minutes, I'm going to go ahead and put 8 minutes. And I know that 1 mile is a certain number of feet. Okay, so I'm just going to go ahead and change 1 mile into feet. And if you need help, your math notes does tell you that there's 5,280 feet in 1 mile. So now we replaced 5,280 feet with 1 mile. And that's still in 8 minutes. So 5,280 divided by 8 gives you 660 feet for every 1 minute. Now letter D says, how many feet are in 1 second? So we still know, from up here, we know that we can replace, instead of 1 foot, 660 feet. And instead of 1 minute, we can translate that into 60 seconds. So 660 divided by 60 is going to be 11 feet for every 1 second. All right, good job today, guys. Please make sure to continue working hard. Remember to work early, ask questions to Ms. Lands or myself, and we'll get back to you as soon as we can. Thank you very much. Have a good day.